Okay, and we're live. Thank you everyone for viewing into today's live session. My name is Rohit Iyer. I am your student mentor from Upgrad. And today we have with us Professor Chandrasekhar Ramanathan from IIIT-B, who will be taking the session forward. And today we'll be discussing the concepts of data warehousing and how to prepare data. And we'll be answering the questions that have been asked by the students. Professor will be addressing that. And if time permits, we'll take up the questions that pop up during the live chats. So without further ado, it's over to you, Professor.
Okay, thank you. Good morning. Good morning, everyone. Good to be back. So last week we had talked about a few things in R and SQL. So today I will also address a few more things about data warehousing and others. So let me see where to start. So I have received a few questions upfront. Let me begin more discussion-oriented questions, and then I will get on to giving you some examples with R. Okay. So the first question I see here for discussing is what issues are to be considered for performance improvements in SQL? I think I addressed this question at length in the last session. Fundamentally, what we're saying is there are many features within relational database management systems which help you with performance management. So the way I would go about doing it is you as a data analyst, you have to work with the database administrator, DBA. DBA are the people who keep the databases up and running and keep it very healthy, so to speak. So they would know. You have to kind of interact with them depending upon the nature of the usage of your system. And if you tell what are the kind of queries that you are running within the system, then the DBAs will help you fine-tune the performance, right? So as one example I had already given was indexing is one particular example. So the kind of indexing that is required for in a given database depends upon the different kinds of queries that are executed as part of the database, right? Specifically, depends upon the attributes that you use in the where clause, right? So if we say that, for example, retrieve all customers where city equal to Bangalore, then it kind of indicates that the database might do well with an index on city, if that's the kind of query that you are writing very frequently, right? So in general, so there are many such strategies, and most of the times we kind of work very closely with the database administrator to manage the performance of a typical database system. Okay. So let me see what's next. Okay, how do we link R and SQL data sets? I will talk about that in a minute. Yeah, so OLAP cubes helps to have aggregated information on facts spread across multiple dimensions. It's just that we use group by across multiple dimensions, etc. Is there any way or other reason that we form cubes? Okay, so I think the basic question is about cubes themselves. Why do we use cubes, and why is it important, right? So we use cubes for many reasons, right? For example, from a dimensional modeling perspective, if you recall, right, what are the key terms that we used as part of the dimensional model? We said that a dimensional model is comprised of a star schema, so wherein there is a central fact information, or a fact table as we call it, and which is linked with multiple dimensions, isn't it? So when we talk about linked with multiple dimensions, what exactly do we mean? So what we mean is that the most common example I have given, right? So when I present with you a whole list of numbers, just plain numbers, you say, come on, go and analyze this and come back to me. What is it that you can do with a whole bunch of numbers? Okay, as if I'm doing a big favor to you, I'll say, oh, you know what? Those bunch of numbers are supposed to be the profit values, Well, you say, okay, these are all profits. So now, without any additional information, what kind of analysis can I do? Right? I can calculate averages. I can calculate standard deviation, variance, etc. I can do some basic, very, very basic statistics, but I can't do anything barely which is interesting. So you say that, okay, can you give me some more information about these numbers? Now, what do you mean by just dumping these numbers on me? Can you give me more information, right? So that more information is technically referred to as metadata, right? So the heart of data warehousing or analytics, right, is metadata. Without metadata, you can hardly do any analysis, right? So that metadata is called by different names in different methodologies and technologies. That metadata in data warehousing is referred to as dimensions. The same metadata in data mining and machine learning is referred to as features, right? So, but the thing is, at the end of the day, it is a metadata. So now, where does it fit into this big cube thing, right? So why is it called a cube, right? So a cube is it derives its name basically from the mathematics, right? So if you recall your early high school geometry, right, in a geometrical figure, you have these dimensions, right? So you have the x-axis, y-axis. These are nothing but 2 dimensions. That's why we say it is 2-dimensional in nature. So you add as a third axis to it, z-axis, it becomes a third dimension, right? So what are these dimensions, right? So I can have, for example, so if I have numbers 1 to 10 along x-axis, and say 20 to 100 in the y-axis, so that every data point in that xy dimension is characterized by these values of x and y. You say that at the intersection of x equal to 5 and y equal to 20, this is the value we have. There is a value that we have. Okay, so that is the mathematical view of it. If I translate that same thing into data warehousing and star schema and cubes, what happens is, so suppose x is the month, January, February, March, April, May, June, and so on, and then y happens to be store 1, store 2, store 3, and so on. So at the intersection of this x and y values, I can put a number called 10,000, right? That 10,000 could be a profit. So I'll say this 10,000 profit is for the month of March for store S3, which means at the intersection of these x and y values, you have a value called 10,000, right? So this store called S3 and month called March is essentially the metadata associated with the single value called 10,000. So if I have that kind of a metadata with all the data points that I have, now I can do a lot of interesting analysis. I can find out what is happening, which is the most popular month for getting profits, or what is happening in the summer months, in which store are things going well, right? All these kind of analysis I can do. So this is called 2-dimensional data, right? So I can extend it to 3-dimensional data, 4-dimensional data, and so on. Essentially, for the same value of 10,000, I can associate multiple dimensions, right? So the moment you attach multiple dimensions, now you can, I think even in my videos, I use the pictures of a Rubik cube, right? So Rubik cube is a 3-dimensional figure, right? So in that 3-dimensional, associate each dimension with some specific feature. So as I said, one could be store, one could be month, and another one could be a product category, right? So if you look at that 3-dimensional cuboid cube, how many small cubes are there in a typical 3x3x3 cube? 27 small cubes are there, right? So what you should imagine is each of those small cubes is a placeholder for a value, right? So the moment you associate a value inside those little small cubes, then what you're talking about is an n-dimensional cube. So with each of those 27 cubes, I can associate a specific location, I can associate a specific month, I can associate a specific category, isn't it? So that's essentially what that cube modeling is all about. So it is a very, very nice, powerful conceptual way, and which was popularized by Ralph Kimball. He calls it the dimensional modeling. So the moment you design your database, right, not in the as a collection of some random data frames or random tables in a SQL relational database, you organize it specifically conceptually like the star schema, then we are expected to get more value out of this particular thing, right? So how do we get the value? Now, if you by now you must have done enough uh, enough use of Tableau and other tools, right? So if you look at it, if you look at the left-hand side, you'll see measures and dimensions, isn't it? So dimensions. So whenever you do the analysis using Tableau, what do you think is the first thing that you do? Where does your mouse pointer go for dragging, right? Between dimensions and measures, what do you drag into the rows or columns the first? Do you drag measures or do you drag dimensions? Of course, you drag dimensions, right? You drag the store, you drag the month, or I don't know, right? Depending upon what data you're working with, you drag the dimensions because from an analyst perspective, dimensions serve as entry point into that complex cube structure. Okay, so that is why cubes are an extremely popular way of thinking about dimensional data. Okay, and of course from there all those operations of slicing, dicing, everything comes into the picture. Okay, so that is the power of dimensional modeling for dimensional analysis. Okay, so there is a question on drill down and what does it mean? How do you do it in Tableau and R, and what is the use of it in real life? Okay, drill down and the roll up operations are much more relevant and applicable when you're doing visual analytics. Okay, so when you're doing visual analytics, unfortunately, I'm not able to get my Tableau running, so I cannot show it to you in Tableau, but I think you can easily imagine what I'm talking about, right? So it is a simple way to think about drill down. Okay, so let me see if I can. Okay, so just give me a couple of seconds. Maybe let me see if I can quickly load one particular slide and share that with you. Just give me a minute, please. I essentially want to locate the lattice of cuboids slides. Okay, so that is something that I presented in my video. So let me quickly use that to talk about the concept of roll up and drill down. Web operations. Okay, I'm almost there. I'm not almost there. Got it. So I'm going to run it in slideshow mode. Okay, then I will go to this one and do some screen sharing. Application window, dimensional model, share. No, this is the wrong window, I think. Not sharing. Great. Good. So this is the lattice of cuboids. Okay. So let us look at the base cuboid here. So time, location, supplier, and category, right? So these are the dimensions on which I'm having some quantitative data. It could be profits, it could be sales, it could be whatever, right? So when you look at it, start from the bottom, right? It is called the base cuboid. When we go up the lattice, right? So let us consider this particular thing called, let me go all the way to category, right? So let us go to the 1D cuboid called category, right? So here what we're saying is, when I'm looking at this particular 1D cuboid, so I'm having 4 subcuboid which is giving me a summary based on these attributes alone, which means there is a category wise summary, there is a location wise summary, there is a supplier wise summary, and there is a time wise summary. Okay, so what is it that we have done? In my base cuboid, I have information about profits based on 4 dimensions. When I go all the way to 1D cuboid, I'm having only category, right? So suppose there are only 3 categories, right? So there are electronics, there is stationery, and then there are groceries. Suppose there are only these 3 categories. So when I'm talking about sales as my quantitative data, so when I'm looking at it at this 1D cuboid level, I'm looking at 3 values, which is a summary of all the sales that happened across all the locations, across all the suppliers, okay, and across all the time. So which means there is it says, okay, electronics is 1 lakh, right? The groceries is 50,000, and stationery is 5,000. So what are those 5,000, 50,000, and so on? It is nothing but your aggregated value. It could be the total sales, it could be the average sales across different times, across different locations, across different suppliers. So what is it that we have done? This is called a roll-up operation. Okay, so the reverse is drill down operation, which means you are looking up at you are looking at data which is already rolled up, right? So category data. Now you are saying that, oh, this is interesting. So I'm looking at this category data. It tells me that electronics is very high, 50,000. Let me try to study more about that particular category of sales. I want to know what is happening, in different months of this particular category. Which means now I'm saying I'm not interested only at looking at category. I am looking at category and time together. So when I drill down from 1D, I go to 2D. As you can see, in 2D, I can do a drill down analysis involving category with time and category, or category and location, right? So which means when I am drilling down, of course, I have a category and supplier also is there, right? So I can do a drill down by looking into additional details of that particular number called 50,000. Initially, it said 50,000 is for the entire electronic sales. So when I drill down, it says, okay, in the month of January, electronic sales was this much. In the month of February, electronic sales was this much. That is what you get by looking at this subcuboid, this 2D subcuboid called time and category. Similarly, if I look at the subcuboid of time and supplier, it says, oh, this 50,000 rupees of sales for electronics is split across these different suppliers as follows. So this is called a drill down, because I'm drilling down into looking at more details. So that is essentially the application or use of the drill down operation. Clearly, you can keep on drilling down, right? So you say that, oh, okay, time and supplier. So let me drill down further. Let me add location to this mix. I want to know in this particular location, in this month, for this particular supplier, what it is. So you have the 3D cuboid. If you drill down further, you will end up with the base cuboid. Similarly, I can do the reverse operation, right? I can keep on rolling up and rolling up and rolling up. One thing you can notice is the number of data rows, as I keep rolling up, it keeps reducing. isn't it? Because what is it that I'm doing? I'm summarizing the data, right? If there are only three distinct categories, when I'm up here all the way at the 1D cuboid, I will have only as many rows as there are categories. When I'm looking at this time as a 1D cuboid, I will have only as many rows as there are distinct time intervals in my data set, right? If my data is organized month wise, I will have January, February, March, and then 12 such rows will be there. Distinct locations are there, and supplier. So which is really small in number compared to your base cuboid. Okay, here's a trick question. How many rows do you think will be there in the apex cuboid? All. Okay, I can't hear your answer, but if you did say one, you can give yourself a pat in the back, because that's exactly what it is, right? Which is a global summary. It is taking whatever values, all the numerical values that is there, and then it will summarize it using whatever summary operation that you have chosen: minimum, maximum, average, total, whatever you want. So that is called the apex cuboid, right? So hopefully that kind of explains the drill down and roll up are kind of complementary to each other. Okay, so let me kind of yeah. So now how do you do it in Tableau? So in Tableau, and you can do it very nicely in Excel as well, Tableau and Excel. So essentially the process of roll up is, no, when you have a rolled up, when you have a very detailed view, when you remove dimensions from them, then it is essentially the process of roll up, right? When the process of drill down is done in Tableau by dragging more dimensions and adding it to either the rows or columns. That's how you do drill down. So when I remove dimensions from the rows and columns, then the process is called roll up. Okay, that's essentially what it is. So let me give you quickly tell you that you have to be very conscious with the terminology here. So slice and dice is a very simple operation. There is no aggregation involved in here. So slice and dice is nothing but doing simple filtering on the data, right? So when you say that I have 10,000 rows of data. So if I want to look at only one specific dimension, for example, if you have data about say 100 stores, you want to look at the data of only one store, then that process is called it's called slice, because you are slicing along one dimension, right? So when your filter condition involves only one dimension, it is called a slice. And when your filter condition involves more than one condition, it is called a dice. Okay, so the metaphor is kind of understandable. So it's as if you're chopping your tomatoes. If you run your knife in two directions, it is called excuse me, it's called a slice dice operation. So in the same thing, so if you are saying I want to look at data for the month of March in the category of electronics, so you have two dimensions here: your category dimension, you have time dimension, and then you have specified March and electronics. So that is essentially your dice operation. And doing it in many of the visual analytics tools is very straightforward. Okay, and of course, how do you do it in R? In R, it is not that interactive, but you will essentially, whenever you are doing an aggregate operation, that's where you are rolling up. So depending upon the attributes that you have included in the aggregate operation, you might get more operations, more granularity. Okay, so hopefully that addresses the question on roll up and drill down. Okay, so what other questions do we have? Okay, so let me jump into my R window now and just illustrate a few things. There is my R window. Okay. Hey, I ended up sharing the slides window. Strange, my R window is not appearing. Nope. I have not been having a great time with Hangout today. With the Hangout window, not the session though. Okay, so what I will do is let me open it in gedit and walk you through the code. Okay, so hopefully you're able to see the R window here. Okay. Okay, so there was a question about this one. In the province making the maximum loss, which shipping mode is contributing most to this particular loss and so on. So essentially, this is a bit of a slice and dice doing it in R, right? So before I show you how to do it in R, I'm assuming you know how you can do it in Tableau, right? So how do you do it in Tableau? I'm unable to show you the Tableau window here. So how you do it in Tableau is that you load the Superstore data set, and then we want to look at the province that is making the maximum loss, okay? And which shipping mode is contributing most to this particular loss. So when given the question like this, you have to be you should be able to spot what are the dimensions here and what are the measures here, right, or facts, right? So the province, is it a dimension or a measure? It's a dimension. Shipping mode, it's a dimension. Loss or profit, it is a measure, right? It's a quantitative attribute. This is a factor in our language. In data warehousing language, it is called a dimension. this is also a dimension, right? So hopefully you know how to distinguish between a dimension and a fact, between a categorical variable and a quantitative variable, and between a factor and a numeric variable, right? So that's essentially, that is the first thing that you have to know how to distinguish. Once we know that, the rest of the activity is pretty straightforward, right? So you can drag and drop your province into rows and shipping mode into columns, and then columns are rows, and effectively the profit is something that you drag into the rows or columns. It will tell you what is the profit, and if the profit is in negative, then it means it's an actual loss. So you can clearly see the summary that Texas is the province which is having the maximum amount of loss, and within Texas, the moment you put shipping mode into the mix, you will also see that the standard shipping mode is probably contributing most to this particular loss. Okay, so let us see how to do it in R. Okay, in R, what I have shown here, I will share the script with you. We can I have deliberately made it into multiple steps for illustrative purposes. So I have loaded my data, and so this is the sample data. Okay, so the first thing is the aggregate operator. So I want to find out province-wise profit. Okay, so for that I'm using this aggregate function, right? So what is it that I want to aggregate? I want to aggregate, whenever you are trying to aggregate, you will use one quantitative variable and one or more dimensional or factor variables. In this particular case, I have used the factor variable called state. Okay, and orders, this is the second parameter. So you can see that the notation for this is nice. So it uses a little tilde symbol to separate the fact variable that you want to summarize with the dimension based variable on which you want to do a summary, right? So quickly, what operation is this in the OLAP operation terminology? Is this slice, dice, roll up, or drill down? Yes, this is roll up. I am rolling up my entire profit into the state wise summary, right? So this is a roll up operation. This is how you do roll up in R. Okay, and orders, the next parameter is the data set, because I loaded my data set into the orders data frame, and this is an important argument, right? So the next argument says, what is the aggregate function that you want to use for summarizing this, right? So I'm saying I want to total it all up, and then figure out whether I'm doing my net is a profit or a loss. So I am summing it up. Now state profits sorted. Okay, so hopefully there are no questions. This is quite straightforward. So let me run this one first. So I run state profits. So maybe we can quickly look at the state profits. State profits. So you can see that state-wise profit values are given. So if I scroll this a little bit, right, sure enough, Texas is there at negative 25,729. Pennsylvania is at negative 15,500. So Texas is the state which has province which is making the highest number of loss. So this I am able to tell by visually looking at it. How do you programmatically extract this? Okay, so then what I do is, so to programmatically extract this, I choose to sort it. Okay, now I have combined two commands into the single thing, right? The first thing I'm using the order command in R. Okay, in the last Hangout session, I tried to distinguish between order and sort. Okay, order, sort, when you run the sort command on a set of numbers, it will return the sorted values themselves. Okay, for example, if I have three numbers 10, 20, and 30, suppose it is 20, 10, and 30. if I sort 20, 10, and 30, the output I get is 10, 20, and 30. Okay. If I run the order command on this one, it will give me the index locations of the sorted order. So if it happens to be 20, 10, and 30, the output of the sort function will be 2, 1, and 3, because the lowest value is in the second position, the next highest value is in the first position. So it returns the sorted positions. Okay. In general, we don't use sort, we use order. Why so? Because order can it returns a set of index values. So if I have a large data frames with lots and lots of columns, right? So I want and all the columns in my output, right? Because I'm not just interested in sorted profits. I am interested in sorted profits along with other information like shipping mode and so on, which is associated with those profit values, right? So what I wanted here is, I am saying I am interested in the state profits. So what are the attributes in the state profits? So let me say head state profits. So there are two columns, state and profit. So I want the output to be sorted to include the state as well, because I want to find out which state is at the top or at the bottom, right? So that is why I am using the order. Okay. Then I take the ordered index values and I apply it on my state profits. Using the square brackets notation, I am fixing the order in which the index values, the row index values that I want to see in my output. And after comma, I have not specified any attribute, which means I want all the attributes of this state profits. Okay. So let me run this line. So now if I say head of state profits sorted, so now I can see that Texas is coming up way at the top, right? So I have ordered it on ascending order. So which means the smallest value shows up at the top. So that is my first value, right? So once I have the sorted value, where do you think the state that I am interested in? I'm interested in the very first row. So what I do from this one, I say the most lossy state happens to be the state profit sorted. I'll just pick the first row. Okay. I know that there was another question. What do we do if what do I do if there is this particular approach? What it will do is, if there is only one unique least value, it will return only the first, right? So this will not work if there are two states which have the same least profit. Okay, how to address that, I will come back to that later. But so let's proceed with this one. So the most lossy state, can we see what is the most lossy state? Lossy. Lo and behold, I have only the first row with me, right? So if you are not interested in both the attributes, you can simply say most lossy state, $state will give you the name of the state. Okay, but then we said, what about the shipping details in that state? Because we want to now drill down, right? So I want to drill down into this particular state. Okay, this is a beautiful illustration of a combination of roll up and drill down. So first I have rolled up to the state level. Then I have zeroed in on one particular state that I want to analyze. I want to blow up. I want to drill down into that particular state, right? So how do I go about doing it? So what I will do is, I want to extract the shipping information for that particular state. So I use this subset command. I go back to my base data frame, which is called orders. I apply the filter saying that order $state equal to most lossy state $state. Right? So this is the filter condition I'm specifying. And then I'm going to say what I am interested in is select equal to, I'm interested in only the, I'm interested in only the state column, and I'm interested in the shipment mode and the profits associated with it. Right? So these are the only three columns that I need to figure out which is the shipping mode which is contributing to the loss, overall loss. Okay. So I try to find out the lossy states shipping by running the filter condition, right? So Control L. So lossy, I'll just take the head, lossy state shipping. Right. So now this contains only information about Texas. So there are so many orders that have been placed, some standard orders and so on, right? So I'm seeing what's going on with the profit, right? So I have full details about Texas here, right? So how do I create now? I want to see, I want to create a summary based on shipping mode now, right? So lossy state shipping summary is nothing but the aggregate function of profit with respect to shipping mode. Okay, the data frame on which I want to do that is a lossy state shipping, which means I want to operate on this data frame, and the aggregate function I want to use is essentially my summary. Okay, so lossy state shipping summary. Shall we quickly take a look at the summary? Lossy state shipping summary. Right? So it says shipping mode and the profit. So first class is this much, same day is this much, second class is this much, standard class is this much, right? Again, I do the same thing. I take this one, I sort it, and in this one, I'm combining multiple things. I'm just taking the first row directly here. In the previous example, just for the illustrative purpose, I did it in all separate commands, but I can actually take the first row here after ordering it, only the first element, and then retrieve only that one. So if I say most lossy shipping, if I look at the value now, most lossy shipping is essentially your standard class, wherein I'm losing about 19,952. Okay, so this is a very nice illustration of how do you use it in an analytic scenario, right? How do you use drill down and roll up in an analytic scenario? To summarize, most of the times we begin by rolling up to the highest level. Then we try to zero in on specific topics of interest by drilling down into specific dimensions, right? In this particular case, I drill down on the specific dimension of state equal to Texas to figure out, and because I wanted to know what is happening in Texas. And why Texas? Because Texas happened to be the least profitable of all the companies or whatever provinces. Okay, that explains the roll up drill down operations in R, and also how to answer that specific question. Okay. And then there was another question about how do I link up R and SQL. SQL is essentially a relational database. Okay. So to do that, the first thing you have to do is you have to install the R MySQL library. Okay. So what you can do is you can go to tools, install packages, and then type R MySQL. I'm assuming you are using the MySQL database. Let me back up just a little bit and quickly tell you how this is going to work. Okay. If you can give me a minute, maybe I don't have that. If you can just give me a minute, I think I might have a picture which will illustrate that for you. Never mind. I'll talk through this. No problem. Okay. So hopefully you're able to see my R screen here. So, okay. So before I get into the specific commands and so on, I quickly want to summarize how does Tableau work with relational databases. Okay. In a typical relational database, there are two parts to it. There is a client and there is a server. Okay. So the MySQL database example that you're using here is called the server. And if you're using R to retrieve the data, then R becomes the client. On the other hand, you already must have used the MySQL command line client for retrieving data, or MySQL workbench for retrieving data from a MySQL database. So they are also examples of database clients. Okay, which means for a given server, there can be any number of clients. So to make different clients work with the server, there are intermediate link software that is needed. Okay, that link software is generally referred to as a driver. Okay, so you need a driver. So for any client to connect to any server database, I need the drivers. Drivers are specific to the specific DBMS product that you're using, which means there is a separate driver for MySQL, there is a separate driver for Oracle, there is a separate driver for MS SQL Server, there is a separate driver for DB2, and so on. So every relational database will have its own driver. Okay, so to put it all together, so I have a client, I have a server, I have a specific server. Suppose I have a MySQL server. So if a client wants to connect to a MySQL server, I need to use a MySQL driver, right? So driver is that intermediary link software. Similarly, R also can be used as a client to a relational database. When you want to use R as a client to MySQL relational database, you need to use MySQL driver. Okay, so that is what we are going to do first, right? So when I am installing this particular library, so what it will do is it will install the requisite libraries for you. What it also means is that the example that I have illustrated here works only with MySQL, right? Because the library that is here and the driver that I'm using in this example works only with MySQL, right? So if I want a a different database, I need to figure out from the vendor, or I don't know. So there must be some help pages from where you can use that particular. There will be a specific name given to that particular library and the driver. You have to ensure that you install that. So first you install the R MySQL library. Then you load that particular library. So let us go ahead and load it. Let me clear this window. Okay, so I have loaded my library because I have already installed it before the session started. So this is the first thing that any client is supposed to do when I want to retrieve data from a relational database, okay, which is called establishing a connection. Okay, in R, the way you do it is by using this particular command called dbconnect. The first argument says that I want to use MySQL driver. Okay, so this is where you specify which driver you want to use. This is where you specify what is the library you want to use. This is where you specify what is the specific database driver you want to use. What is the username and password? Oops, I have revealed my ID and password. Well, don't worry, this is just my test database. But under in real production conditions, this is probably not the way you would be doing it. you would not be setting up the user ID and password openly in this manner. What you should be doing is you should set up your ID and password. I mean, I think you should work with your database administrator. They will help you. So there is a MySQL file called my.cnf. Inside the my.cnf, you can specify the ID and password and make that particular file really a big secret. You can say you don't have to show that particular file to anybody. And then what you can do is you can set up other authentication mechanisms so that this particular script is able to securely connect to the database without explicitly specifying the ID and password inside your source code. Okay. But anyway, since anyway we are doing a little demo here, we will go ahead and include it right here in the code itself. So you have user ID and password, and the next argument is the host. Host is what is the where is the server? What is the IP address of the server where your database server is running? So in this particular case, I'm just specifying it as a local host because it is running on my laptop here. Okay, and if it happens to be running in some other server, I think all of you were given a MySQL server which is running on in the AWS Amazon Web Service. Then you can go to the Amazon Web Service, try to figure out what is the IP address associated with that particular database MySQL server that you're using. You should put that number here. Okay, and then DB name is nothing but the name of the database. I'm going to use this simple illustrative example database called company DB, and client.flag is client multi results. You don't have to bother about it, but yes, this is useful when you are fetching multiple results from a single query. Okay, so just remember to set it to multi requests as given here. Okay, that's it. So this is an important step wherein you have to establish connection to a database. Okay, so this is to be done. What we say is for every program, it should be done only once, exactly once, right? So what we say, we don't call them as programs. For a session, right? For an interaction, for a given session of interaction with the database, you establish the connection once. Then you create your queries. Okay, so here I have created a query in the form of a simple string. Okay, so I don't remember if I created the connection. So let me go ahead and create the connection. Right, so my connection is created. Then my query is select star from employee where D number equal to 4. Okay, so let me quickly switch to my MySQL window. MySQL minus root minus b root use company DB. Okay, so show tables. There will be many tables. So my query is on select star from employee where D number equal to 4. Okay, select star from employee where D equal to 4. Okay, so this is I think it's returning 3 rows with all the attributes: first name, middle initial, last name, and so on. Right? So if I want to get this data into R, how do I go about doing it? So you write the query, whatever query you want to write. So here you can put in any valid SQL statement. Okay. So I load that particular query into a simple string. Note that I've just loaded this into a string. I have not executed my query yet. Okay. So my query is simply sitting in my string in the form of a string. Okay. There is no real effect that's happening here. Okay. So my suggestion is that before you actually put the query in here, like the way I did, make sure to run that particular query in the MySQL command prompt to make sure there are no syntax errors in your SQL query. But this is the line number 34 is the crucial line wherein you are actually executing the query. Okay, so I will say result set df1 equal to db get query con my query. So db get query is the command that is used to execute the queries. Okay, it takes two parameters. The first parameter is the connection. You remember we just created a connection here. You have to specify what is the connection object here. And then the second one is a string, which is the SQL statement, right? You might as well have put double quotes and type this entire query here, but that is not a good idea. Generally, it's a good idea to write the string into a string variable and then use that variable name here. So let us run this. Okay. So if I look at the, let us see, head, let's say class result set f1, which is a data frame, right? So what has happened now? It has executed that particular query. The entire output of that it has stored into a data frame called result df1. As simply chosen to name it as result df1, you might as well have chosen this to any name, assigned it to any variable. Okay. So if I look at the data itself, head result df1, you can see that there are 3 rows. Right, exactly the same output that you saw inside database, right? So what is it that we have done? We have retrieved, we ran the query, right? So this is where the client server concept understanding that would be useful. So what has happened? Your R code is runtime is acting as a client. It sends the query, whatever query you have given, over the network to the database server. And who is going to take it to the database server? It is the driver, right? So driver takes it all the way to the database server, and the database will execute this particular query. Where will it execute this particular query? In the database specified in this particular connection. Okay. And inside the connection, what have we specified? We specified what is the IP address, we specified what is the name of the database, and so on. So the driver now knows that I am supposed to go to this particular server, connect to this particular database, and ask the DBMS. Remember, the driver is not the one which is actually executing this particular query. The driver's job ends when it goes and delivers this particular query to the server. Once at the server will kick in, and then it will execute this particular query. So that is why in the last class also I was in the session I was mentioning, somebody was asking, when I am writing this SQL thing queries in R, what are the performance considerations and so on? See, there is hardly any performance tuning of the SQL you can do within R, because the execution of this particular thing is being done by the DBMS in the backend or in the server. Right, as I said, the database management systems are quite powerful. They will optimize it for you to the best possible extent and execute it. Right, so generally, you don't have to worry about it. Okay. Okay. So when only half the job is done by the driver when it has given the query there. Right, so back to the server. Now the database server has executed the query. It has retrieved these particular rows. It has to bring it back. So the driver once again collects the results. Okay, gives it back to this particular db get query function, which in turn will assign it back to the result df. Okay, once it is in result df, the whole thing is under your control. Okay. So the data is sitting inside a data frame inside the R environment. So what I can do is I can create another query. I've changed the query now. I said select F name, D name, salary from employee E, department D, where E dot D now equal to D dot D number. Can you recognize what kind of a query is this? Of course, this is a join query. Whenever you see more than one table in the from clause, immediately it should occur to you that I am probably doing a join. Okay, so and then I can execute the second query as well. So what I want to illustrate here is that is the fact that even when I run multiple queries, once I have saved the result into my data frames, I don't have to worry about it. So using the same database connection, I can run multiple queries. So you will notice that between running the second query and the first query, I did not establish connection to the database again. I'm using the same connection object, right? So which is perfectly fine, right? In fact, this is the way you should do it. It is a very bad idea to keep creating connection every time you want to execute a SQL query, right? So you can clearly see in the second case, I have stored the result in a data frame called df2. Let us quickly look at what is there in result df2, right? So it has got these 8 rows with name, salary, and name, dname, and salary, right? Okay, so this is how you can you can link to relational databases. A few other things, right? Now I have a data frame. I want to be careful when using the word called linking. Okay, I have not really linked this data frame called df1 with this table called employee, because what linking would entail is that whenever I'm inserting new data into the employee database, my data frame will automatically get updated. That is not going to happen here. Okay, for example, if I go into MySQL here, okay, describe employee. Okay, so let us try to insert into employee values. So f name xyz, eminent x, abc is the last name, 3 is the ssn, 20 2000 01 01 ddmmyy. PQR is my address. Gender is salary is 10,000 or 1,000, whatever. Super SSN, I will assign some null value, and D number 4 or 4. Okay, I'll just read it. Let us insert this particular row. So it has inserted one row, right? So if I see select count star from employee, okay, I have 9 rows here. Okay, so when I have 9 rows here, whereas in result frame, right, in df1 we have said select star from employee where dno equal to 4. Oh, okay, so let us run that particular query. I think I ran it earlier. Yeah. So dno contains 4 rows here. Dno number 4 contains 4 rows. Okay, and that is the query that I ran earlier. If I now see the result df1, guess what? It contains only 3 rows. So what happened to the 4th row? The 4th row still remains in the database. It has not come to the client, right? So this is something that that is why I don't want to use the word called linking. I have not really linking. I have only connected to the database and retrieved the data, right? So which means when your database, when you want to update the data in your data frames, you have to run the query once again. Okay, so let me run this particular query once again. Now, if I try to see the result, you will find, okay, sorry, that's the wrong data frame. DF1. Okay, so now you will see there are 4 rows. The 4th row, the XYZ row that I installed, that I inserted, will show up. So it will show up, it will get refreshed only when you explicitly run the query. So this is something that I want you to remember. Okay, so that's pretty much here. So you can write as many queries as you want to retrieve the data. And after you are done with reading all the data that you want, you can and you must disconnect from the database, because utilizing this particular connection, keeping it open, will utilize lots of resources. So you cannot you will run out of memory and you will have other such problems. Okay, so once you have disconnected, if you want to read data from the database, you must establish the connection again. Otherwise, you will get an error. Okay, so for example, if I try to run this query again, so you can see that it is saying corrupt connection handle, because you are trying to run the query on this particular connection after calling the disconnect object connection. Okay, so hopefully that explains how to retrieve data from a relational database. Okay, as I said, even after, one more thing I want to tell you is that you can work with the data frames into which you have loaded the database data from the database even after disconnect. Okay, you will not get any error. Okay, you will get error if you try to use the connection object to run the db get query, but I suppose I want to simply do an aggregate, right, of salary, dname, and so on. I can simply run this. So if you recall, this result df2 data was populated using an SQL statement, and I have now disconnected from the database, right? So it is perfectly fine to work with the data after disconnecting from the database. Okay, so because, as I said, for all practical purpose, I have copied the data from the relational SQL database into a data frame in my R environment. Okay, so hopefully that kind of clarifies several important concepts. Whenever you want to work between combine data from R and SQL. Okay, yeah, and although this particular illustration uses MySQL for illustration, R can read from several RDBMS systems, including Oracle, Sybase, Postgres, SQLite, and so on. Okay, if you go to the R website, there is a R data import export guide. Okay, so you please refer to that, and you can use this. In fact, you can also use it to store data into the relational database and so on. Okay, all right, good. Let me move to the simple. I think there was one more question, right? So yeah, we had one unanswered question earlier. So when you said that, the way we have been doing, right? Finding the highest salary or highest profit or least profit and so on. The normal way that you would do is not really generic enough. I think that is. I'm very glad someone actually thought about it and asked that particular question, right? So the question, let me put up that question here. Yeah, Radha Ranjan Madhav. So, right. So the solution is not generic enough, right? So what if I want to find a second successful movie, third successful movie, second most profitable, and so on? These are these are generally referred to as top n queries. Okay. So straight away, that is the way we have seen it in R or SQL is not the most ideal way to do top n queries. Okay. So let me tell you give you one very compelling information here. Okay. One of the things that we have always been saying is that the SQL, we try to distinguish between OLTP systems and OLAP systems, online transaction processing systems and online analytical processing systems, right? So one of the things we kept saying is that the purpose of the system itself is of an OLTP system is very different. So the SQL language is not intended for analytics. Okay. So this is the reason why I have emphasized several times. Okay. Let us not try to twist SQL into doing something which it is not intended to do. Okay. So to be very specific, there is no way to do a top n query in SQL. There's no, let me put it this way, there is no straightforward way to do a top n query directly in SQL as per the SQL standard. There is nothing in the SQL standard. Okay. So what has happened was many of the vendors have gone ahead and added these as additional constructs, okay, which are additional plugins into their DBMS products. For example, these kind of top-end queries are available in Microsoft SQL Server in their analysis services. Okay, Microsoft SQL Server analysis services is a separate piece of software which gives you the ability to do top-end analysis and many more analytical functions. Okay, so please remember, so no matter what anybody tells you, SQL standard core SQL does not contain top-end queries. Having said that, there are many product extensions that you should be familiar with depending upon the product that you're using. So having said that, I have also not come across any analytic function support in MySQL. Okay, the only any advanced analytic function support in MySQL. Okay, MySQL supports the standard aggregate functions, min, max, average, sum, etc. Okay, but it does not support analytic functions directly. Okay, so you can Google for it and then install some additional plugins. Maybe it will work. Okay, so coming to R. Okay, so how do you do a top-end kind of a query in R, which is much more generic instead of simply, what we have done here in my earlier example is I admit this is not generic enough, right? So this will be incorrect if there are two states because we have hard-coded one here. What if both the first and the second state have the same value and I will miss out that particular thing in this particular information? So for that, how do you address it? You use you address it using this function called rank function. Okay, so how does it work? So let us illustrate it with a simple example. So suppose X is my data set with values 100, 200, 300, and 400, right? So you can, suppose I say invoke rank on X, it is going to tell me that the rank is, the first value of 100 is having rank 1, second value is having rank 2, third value is having rank 3, and fourth value is having rank 4. Okay, so if I jumble up, so let us jumble up a little bit. 200, 100, 300, 400. Then I do the rank of X. So it now changes to 1, 3, 4. Okay, so this is a simple ascending order ranking. So you can similarly do a descending order ranking. So there is an order parameter that you can specify. You can reorder your data set and then no the rank parameters, and then you can create a different types of ranking. Okay, but let us now focus on the other main issue that we have. Suppose 400 appears twice here. Okay, so I'm going to modify my data. Okay, so you can look at the data clearly. It contains 400, 100, 300, 400. Okay, so what is the output that we expect? Okay, one output that we expect is that the fact that this is rank number 1, this is rank number 2, and this is jointly rank number 3. Okay, so that is one kind of an output that we can expect. Okay, it supports multiple ways of resolving whenever these multiple values are occurring. Okay, so let me just run the default. I will not specify how to deal with ties. Can you see what it has done? It has said 100 is rank number 1, which is fine. 300 is rank number 2, which is also fine. Then I have 400 appearing twice. Okay, so these are vying for locations position 3 and 4. Okay, so how do I decide whether this is 3 and this is 4? Okay, can I decide? Do I want to decide? So instead what I say is, okay, so don't fight it out, we'll take an average. So I will say you are 3.5, you are 3.5. So that is why it returns a rank of 3.5. So that is, there is an additional parameter called ties dot method. There are different methods that it supports to break the tie. One approach is to use the average, which is the default. Okay, suppose I say first. Okay, let us see what happens. The same data set, suppose I rank it and then say ties dot method equal to first. Okay, so what has happened? My 400, okay, 400 got a rank of 3 because it is appearing first between this 400 and this 400. So this 400 is appearing first. So I assign it a higher rank, and so the order in which they are appearing. So this is appearing first, and this is appearing this thing last. So I myself curious what will happen if I run it with max and min. Let us see what will happen if I run it with max. If I run it with max, it is assigning the max rank to all those values. Okay, and I can imagine, I'm going to guess that if I run min, it is going to assign 1 to all of them. Yeah, essentially between 3 and 4, right? So this is what our initial intuition was, right? Between 1, 2, 3, and 4. So if they are vying for position 3, 4, 5, 6, let us put it that way. If you have a tiebreaker of 4 values which are vying for positions 3, 4, 5, and 6, the options available are, I take an average of 3, 4, 5, 6, or I assign it as 3, or I assign it as 6. That is the min, max, average method. And then apparently it also supports random. I don't know why I would want to put random. Okay, so this probably is a much better way of solving, figuring out the top n query. So as a little exercise, what you can do is, I want you to go and modify this particular code that we wrote. Shipping mode is contributing most to this particular loss, or in the province which is making the maximum loss. Instead of hard coding this particular one, can you try ranking the state's profits, state profit, dollar profit? Use the rank function instead of the order function, and I don't know, so you solve it. Okay, so do that as a little exercise, and if you face any problem, then you can post it on the discussion forum. Okay, so that pretty much addresses all the questions, I think. Okay, great. I think so. We are just about up with our time, and I'm glad I was able to cover everything that I wanted to as part of the questions that were asked. So what I was suggesting was, if there are um, any more leftover questions, especially if it is going to involve some amount of complex coding kind of a thing, so you send it to me. I will I'll respond back, and they will upload it to you in the discussion forums or wherever, and you can use it. Okay, so if there are any high level questions, maybe I can take one or two. Otherwise, I'll take them as offline response.
Professor, we're just about up with the time, so I suppose I'll be sending all the questions to you as a transcript, so you can just reply to all those questions, and we'll circulate it among the students later on.
Okay. Yeah. Sorry, I missed one query, I think, which was included in the questions that was asked. What are the packages available for NLP? Right. I should admit, R, as far as R is concerned, R is a little weak on NLP side. Okay. So if you look at the evolution of R itself, R evolved more as a statistical package, right? So as a statistical package, most of the times you're dealing with numbers and those kind of data. And the natural language processing is relatively new as far as R is concerned. So I wouldn't do very extensive NLP text mining kind of analytics with R. For that, Python will win hands down any day. So there are lots of nice packages in Python. I did see that there is a package. There is a package called NLP, but this goes back to one of the questions saying, how do you choose packages? So one of the things that I look for immediately when I come across a package is, what is its evolution history, right? How much of development has gone into it, what is the evolution, and so on. So the version number of the NLP package, the package itself is called NLP. You can search for it and install it. It is still in 0.1 version, okay, which means the developers are still working hard to add more and more capabilities to that particular package. It also indicates that it is probably not ready for showtime yet. I've also come across another package called OpenNLP. You can check it out. I have not had an opportunity to look into that, but any amount of serious text mining and NLP, you should probably go to Python. Okay. All right. I think that's all from my side.
Okay, so thank you so much, Professor, for providing your insights. And thank you all for viewing today's live session. And have a great day. Bye bye.
Thank you, everyone. Bye bye.